What if the silence isn't natural? What if the emptiness we see when we look up at the night sky isn't coincidence, but consequence? Right now, at this very moment, there are approximately 200 billion trillion stars burning across the observable universe. Statistically, millions, perhaps billions of civilizations should exist. Yet when we listen, we hear nothing. When we search, we find no one. The Great Filter Theory suggests that something stops civilizations from spreading across the cosmos, something catastrophic, something inevitable. And the terrifying question isn't whether this filter exists, it's whether we've already passed through it, or if it still lies ahead, waiting. Today, we journey through evidence that challenges everything we believe about life, intelligence, and survival in the cosmos. We'll examine why the universe might be empty by design, by destruction, or by laws we don't yet understand. Prepare yourselves. We begin. In 1950, during a casual lunch conversation at Los Alamos National Laboratory, physicist Enrico Fermi posed a question so simple yet so profound that it would haunt scientists for generations. Where is everybody? Fermi had done the math. The Milky Way is roughly 13.6 billion years old. Our Sun, by comparison, is a relative newcomer at just 4.6 billion years. This means there were billions of years for older civilizations to emerge, evolve, and spread across the galaxy. Even traveling at a fraction of light speed, say 1%, a civilization could colonize every star system in the Milky Way in approximately 50 million years. That's barely a cosmic eye blink. Let me put that in perspective. Dinosaurs walked the Earth 65 million years ago. If an alien civilization had begun their expansion just before the dinosaurs appeared, they would have had enough time to visit Earth 13 times over. So where are they? Where are the megastructures harvesting starlight? Where are the radio signals, the waste heat signatures, the evidence of engineering on a cosmic scale? We've been scanning the skies for over 60 years with increasingly sophisticated instruments. We've examined thousands of star systems. We've listened across countless frequencies. And we found nothing. The Fermi Paradox, as it came to be known, presents us with a simple but disturbing equation. Either our assumptions about the prevalence of life are catastrophically wrong, or something prevents civilizations from becoming visible across interstellar distances. In 1996, economist Robin Hanson formalized what many scientists had begun to suspect. He called it the Great Filter, a barrier so difficult to overcome that it prevents the emergence or survival of spacefaring civilizations. Somewhere between the formation of a planet and the colonization of galaxies, there exists a stage that almost no one survives. But the evidence forces us to confront an uncomfortable possibility that we may be looking at our own future written in the silence of the stars. Let's examine what we actually observe. The evidence is not speculation, it's measurement, data, mathematical certainty. In 2009, NASA launched the Kepler Space Telescope. Over 9 years, it monitored 150,000 stars. The results were staggering. Approximately 20 to 50% of stars host planets in their habitable zones, regions where liquid water could exist. In our galaxy alone, that means between 40 and 100 billion potentially habitable planets. The James Webb Space Telescope has since confirmed that many of these worlds possess atmospheres. We've detected water vapor, carbon dioxide, and methane, the basic ingredients for life as we know it. TRAPPIST-1, a system just 40 light-years away, hosts 7 Earth-sized planets, 3 in the habitable zone. TOI 700d receives 86% of the energy Earth gets from our Sun. The universe isn't barren, it's abundant with possibilities. So why is it silent? Consider this. Of the 40 billion potentially habitable planets in our galaxy, approximately 11 billion formed before Earth even existed. Some are 8 billion years old, nearly twice Earth's age. If life emerged on even a fraction of these worlds at the same rate it did here, civilizations could have had billions of years to advance beyond our wildest comprehension.
They could have mastered interstellar travel when life on Earth was still single-celled organisms. They had time. They had resources. They had a head start that defies imagination. And yet, silence. In 2015, researchers at Pennsylvania State University conducted the Gaia Infrared Search for Extraterrestrial Civilizations. They examined 100,000 galaxies looking for the infrared signatures of advanced civilizations, the waste heat that any Kardashev Type II or Type III civilization would inevitably produce when harnessing stellar or galactic energy. The sensitivity was extraordinary. They could have detected a civilization using even 1% of a galaxy's energy output. Result: 0 detections, not a single anomaly that couldn't be explained by natural processes. In our own galaxy, we've conducted targeted searches of over 10 million star systems using the Allen Telescope Array and other instruments. We've monitored specific frequencies that would be ideal for interstellar communication, the cosmic water hole between 1.42 and 1.66 gigahertz, where background noise is minimal. Still, nothing. Evidence 4. Recent discoveries deepen the mystery. In 2023, scientists using the Green Bank Telescope in West Virginia conducted the most comprehensive search yet of the galactic center, the densest concentration of stars in our galaxy, home to 10 million stars within just 33 light-years. If civilizations exist, this would be prime real estate. This would be where we'd expect to find them. They found no evidence of technology, no signals, no industrial signatures. But this is only one piece of a much larger puzzle, because when we examine how civilizations might fail, the evidence becomes truly disturbing. Let's discuss the filters themselves, the potential barriers that could explain the silence. Perhaps the filter lies behind us. Perhaps the emergence of life itself is so improbable that Earth represents a statistical miracle, the only occurrence in billions of worlds. But recent discoveries challenge this comfort. In 2022, researchers found complex organic molecules in the Orion Nebula, 1,350 light-years away, the building blocks of life forming in stellar nurseries. In 2023, the James Webb Space Telescope detected potential biosignatures in the atmosphere of K2-18b, a planet 120 light-years distant. Amino acids have been found in meteorites. Ribose, a sugar essential for RNA, has been detected in interstellar ice. Life's ingredients are everywhere. Chemistry seems to favor complexity. If the early filter were insurmountable, we wouldn't expect to see these precursors scattered so liberally across the cosmos. This forces us toward a more unsettling conclusion. The filter lies ahead. Consider nuclear weapons. We developed them within 70 years of powered flight. We came within minutes of global annihilation during the Cuban Missile Crisis. That was 1962, when our most advanced computer had less processing power than a modern calculator. Now imagine a civilization 1,000 years more advanced. What weapons might they develop? Artificial superintelligence that recursively improves beyond control? Nanotechnology that self-replicates and consumes planetary resources? Manipulation of quantum fields that destabilizes matter itself? In 2014, Stephen Hawking warned that contact with advanced AI or alien civilizations could be the worst mistake in history, not because aliens would be hostile, but because the very technologies required to become spacefaring might also make survival impossible. The statistical horror. Here's what makes this truly terrifying. If the great filter is ahead of us, then every step forward in technology takes us closer to the precipice that destroyed countless civilizations before us. And the evidence suggests we're accelerating. In 1945, we split the atom. In 2012, we achieved artificial neural networks that could recognize images. In 2022, we created AI that could pass medical licensing exams and generate novel proteins. In 2023, we demonstrated nuclear fusion with net energy gain. We're advancing exponentially, but if the filter is technological self-destruction, then our rapid progress isn't a triumph, it's a countdown. The evidence extends beyond simple absence into the realm of probability theory. Nick Bostrom, philosopher at Oxford University, formalized this in 2008. The stronger the silence, the worse our odds. Every empty sky, every silent frequency, every galaxy without megastructures increases the probability that the filter lies ahead. And we're running out of universe to explore where we might find survivors.
So what framework can explain the silence? Scientists have proposed several models, each with profound implications. Model 1, the rare Earth hypothesis. Proposed by Peter Ward and Donald Brownlee in 2000, this suggests that while microbial life might be common, complex life requires such specific conditions that Earth-like planets are extraordinarily rare. You need a star of the right type, age, and metallicity, a planet at precisely the right distance, a large moon to stabilize axial tilt, a Jupiter-like giant to deflect asteroids, plate tectonics to recycle nutrients, a magnetic field to shield from radiation, and perhaps dozens of other factors we haven't identified. But recent exoplanet discoveries have found many worlds meeting these criteria. The hypothesis grows weaker with each new detection. Model 2, the dark forest hypothesis. Proposed by mathematician and science fiction author Liu Cixin, this chilling theory suggests civilizations remain silent out of fear. The universe is a dark forest, and any civilization that reveals itself becomes prey to others who eliminate potential threats preemptively. The logic is brutal but sound. Resources are finite, intentions are unknowable, and survival favors the paranoid. If true, our radio broadcasts for the past century haven't been greetings, they've been warnings to anything listening that a new threat has emerged on Earth. Model 3, the berserker hypothesis. Perhaps the galaxy was once teeming with life, but an early civilization, either biological or artificial, developed self-replicating probes programmed to eliminate competition. These berserkers spread across the galaxy, destroying any emerging civilization before it could become a threat. We may be living in the wake of ancient genocide on a planet that simply hasn't been visited yet. Or we have been visited, and we're being observed to determine if we pose a threat. Model 4, the transcension hypothesis. Futurist John Smart proposed in 2012 that sufficiently advanced civilizations don't expand outward, they expand inward. They miniaturize, optimize, and eventually exist in virtual realities far more interesting than physical space. Why colonize Mars when you can create infinite worlds in quantum computers the size of molecules? If true, advanced civilizations aren't invisible because they're dead, they're invisible because they've moved into computational spaces we can't detect. This forces us to reconsider fundamental assumptions about what advanced even means. Perhaps expansion across the stars isn't a sign of success, but of failure, the desperation of civilizations that haven't learned to transcend their physical limitations. So what framework can explain the silence? Scientists have proposed several models, each with profound implications. Model 1, the rare Earth hypothesis. Proposed by Peter Ward and Donald Brownlee in 2000, this suggests that while microbial life might be common, complex life requires such specific conditions that Earth-like planets are extraordinarily rare. You need a star of the right type, age, and metallicity, a planet at precisely the right distance, a large moon to stabilize axial tilt, a Jupiter-like giant to deflect asteroids, plate tectonics to recycle nutrients, a magnetic field to shield from radiation, and perhaps dozens of other factors we haven't identified. But recent exoplanet discoveries have found many worlds meeting these criteria. The hypothesis grows weaker with each new detection. Model 2, the dark forest hypothesis. Proposed by mathematician and science fiction author Liu Cixin, this chilling theory suggests civilizations remain silent out of fear. The universe is a dark forest, and any civilization that reveals itself becomes prey to others who eliminate potential threats preemptively. The logic is brutal but sound. Resources are finite, intentions are unknowable, and survival favors the paranoid. If true,
Our radio broadcasts for the past century haven't been greetings. They've been warnings to anything listening that a new threat has emerged on Earth. Model 3. The Berserker Hypothesis. Perhaps the galaxy was once teeming with life, but an early civilization, either biological or artificial, developed self-replicating probes programmed to eliminate competition. These berserkers spread across the galaxy, destroying any emerging civilization before it could become a threat. We may be living in the wake of ancient genocide on a planet that simply hasn't been visited yet. Or we have been visited, and we're being observed to determine if we pose a threat. Model 4. The Transcension Hypothesis. Futurist John Smart proposed in 2012 that sufficiently advanced civilizations don't expand outward, they expand inward. They miniaturize, optimize, and eventually exist in virtual realities far more interesting than physical space. Why colonize Mars when you can create infinite worlds in quantum computers the size of molecules? If true, advanced civilizations aren't invisible because they're dead. They're invisible because they've moved into computational spaces we can't detect. This forces us to reconsider fundamental assumptions about what advanced even means. Perhaps expansion across the stars isn't a sign of success, but of failure, the desperation of civilizations that haven't learned to transcend their physical limitations. So what happens next? What can we do with this knowledge? Ongoing research. The search continues with unprecedented sophistication. The square-kilometer array, currently under construction in South Africa and Australia, will be 50 times more sensitive than any existing telescope. When completed in 2028, it will scan billions of star systems simultaneously. The Breakthrough Listen initiative, funded with $100 million, is surveying the million closest stars and the 100 closest galaxies. If anyone is broadcasting, we'll hear them. But perhaps more importantly, we're turning the lens inward, studying our own potential filters. The Global Catastrophic Risk Institute, founded in 2011, studies existential threats, artificial intelligence alignment, bioengineered pandemics, nuclear winter, ecosystem collapse. If the great filter is technological self-destruction, understanding our vulnerabilities becomes humanity's most urgent priority. The Grabby Aliens Model. In 2021, Robin Hanson proposed a new framework, Grabby Aliens. These are civilizations that expand aggressively, colonizing their light cones. Hanson's model suggests we're likely among the earliest civilizations to emerge. We appear early because the universe is still mostly empty. If we wait too long, we'd appear in a galaxy already colonized. This model gives us both hope and urgency. We might have time, but not much. What this means for us. The implications are profound and immediate. If the great filter lies behind us, we have a cosmic responsibility to preserve and spread life. We may be the universe's only chance to understand itself. If the great filter lies ahead, every choice we make about artificial intelligence, nuclear weapons, biotechnology, and climate change becomes an existential decision. We're not just shaping our future, we're determining whether intelligence itself has a future in this galaxy. And if we're being watched, evaluated by civilizations that have survived their own filters, then our behavior right now might determine whether we're welcomed into a galactic community or left to face our challenges alone. Let's venture now into the most mind-bending implications. The simulation question. If civilizations typically develop simulation technology before self-destructing, then statistically we're more likely to exist inside a simulation created by a survivor than in base reality. The empty universe we observe might be a simplified rendering, processing power allocated to Earth while the rest remains dormant. The silence isn't because civilizations don't exist, it's because we're in a controlled environment, an experiment, isolated by design. The zoo hypothesis. Perhaps we're being preserved. Advanced civilizations may have implemented a prime directive, a policy of non-interference with developing species. We're protected, isolated in a preserve, watched but not contacted until we reach some threshold of maturity. The evidence? The absence of evidence. They hide so perfectly that we can't detect them, waiting for us to solve our own problems before initiation. The temporal explanation. What if consciousness itself is the filter? Perhaps the universe is only 13.8 billion years old and we're actually among the first. The silence isn't a grave, it's a waiting room. We're the early arrivals to a party that hasn't started yet. In 1 trillion years, the universe might be blazing with civilizations. We just happen to emerge at the beginning. The most profound implication. But here's the deepest truth the evidence reveals. The great filter forces us to confront our cosmic solitude and our cosmic responsibility simultaneously. If we're alone, then every species that goes extinct on Earth, every language that vanishes, every culture that fades, represents a permanent loss to the universe itself. We are the universe's memory, its consciousness, perhaps its only hope for meaning. And if we're not alone, if the silence conceals a galaxy full of civilizations that didn't make it, then we're reading our future in the archaeological record of worlds that failed. We're walking through a cosmic graveyard, and we need to learn from the epitaphs written in empty space. The universe is empty for a reason, and the terrifying truth is that we still don't know if that reason is behind us or waiting ahead in our own future. We began with a question, where is everybody? Now we understand that the answer matters less than what we do with the uncertainty. The evidence shows us a universe rich with potential, but silent with absence. We've found the ingredients for life scattered across the cosmos. We've discovered thousands of worlds where life could emerge. We've developed the tools to detect civilizations across galactic distances. And we've found nothing. This silence is either our greatest tragedy or our greatest opportunity. It's a mirror reflecting our own fragility and our own potential. Every choice we make about our technology, our environment, our survival, these aren't just political or social decisions, they're cosmic trials that countless civilizations may have failed. But we have something they might not have had: awareness. We know the filter might exist. We can choose to be careful, to be wise, to value survival over pride, cooperation over conquest. The universe is vast. It contains 200 billion trillion stars, 40 billion potentially habitable planets in our galaxy alone, and 13.8 billion years of cosmic history. The mysteries are endless. Why are we here? Are we alone? Will we survive? But perhaps the most important question isn't whether life exists elsewhere, it's whether we'll be the civilization that finally breaks the silence. The journey continues, and for now, the universe is watching to see what we'll do next.